Hello all and welcome back. So in this video, let us continue our discussion on stacks. And now let's see how we can implement stack using linked list. So let's get started. Now in the last few videos, we saw what exactly a stack is and how can we implement the same using the inbuilt list, right? We have also seen the overall visualization and exactly how the operations gets performed. Now, if you remember, when we were understanding about linked list, I told that linked list can actually be used anywhere we are using our list or an array. So with that mind, I think we should be able to implement our stack using linked list as well. Okay. So now let us understand and go back to our linked list understanding overall what we all know about linked list. In a linked list, we deal in terms of nodes. So we don't have any memory as such. We will be creating these nodes as and when it will be required to us. Now, the very basic idea, which of course each and every one of us can think, that we can, to implement stack, make sure that using the nodes of a linked list to store that data. Stack will be storing some data. We have to make sure that using linked list and the nodes in our linked list, we are able to store that data. So let us imagine a stack. Okay, one second, let me draw it nicely. So let us imagine that this is one stack which is with us. Okay, and in this stack, I am now trying to add some elements. So when I try to add some elements, everyone, we have to make sure that we will be able to mimic the same behavior in our linked list. So let's see that in action. Great. Let me just make it type. Well, yeah. Great. So the very first thing which I am doing is I am adding an element 1 in my stack. Okay, great. So what I can do here, I can just create a node which is having 1 and I can say that this is my head of a linked list, right? So this is the very basic idea that yes, we know about linked list. We know that how we can store data in linked list. So we are just trying to use it for our stack. Now let's say you store another element which is 2. So no worries here as well, everyone. We can of course make a copy of our node, or rather we can make another node and then combine both of these, right? So we know how to connect them and we can connect them like this, right? So this will be having the data 2 and now it will not be none. So this is how we can do that. Great. So let us actually write down the operations as well. So we have a good idea. We have the overall push operation, which we are able to see that we are able to do here. Okay, so push is fine. Second, let's say size operation. Okay, I believe size will also be a lot easy. You just have to make your temp variable and make sure that you traverse each and every of this linked list node and you can get your size, right? So size I think can also be done. Third can be is empty, which again I think is the easiest to make sure that you can do is empty. You can implement is empty. We can just check if our head is none. If our head is none, then we can say that is empty is getting implemented, right? Great. Now let us talk a little bit about the complexities which are involved first in these functions. Okay. So for push operation, if I am just storing the head, then if all of you remember, we discussed that how when we were even taking the input of our linked list, the complexity was coming out to be O(n) square. Okay, so if you have not seen that video, please go back and just try to see that take input of a linked list video. We used to create a temp and then we used to keep on moving our temporary variable. Okay, so let me do one thing. Let me make another one of these nodes which we can copy. So this is our node and let's say another one. Okay, so I'm making these 4 nodes, which in a way tells that there are 4 elements in my stack. Great. So this will be clear. Now let me just make them 3 and 4 as well. 3 and 4. And here also I can say that this is 3 and this is 4. Great. So our stack and linked list right now are in sync. One problem which I feel is there in push function, push operation, is that it will be taking O n square, right? So maybe we can write that down as well. Let me remove the other functions and write down the problem. It will be implemented in O n square complexity, right? O n square complexity. Now we are aware that how this is a bad complexity and something which we should be avoiding, right everyone? Because if out of these basics operation which I'm doing in a stack, just pushing is taking O n square time, then I think that is a lot bad. We have seen that how it will be even better than to just directly use an array or something, right? So we have to do something so that we can correct this overall complexity. Great everyone. So of course, having an O n square complexity is not good and we have to do something through which we can avoid the same. Now we have discussed this a lots of time again that we can maintain a tail variable. Okay, so maybe I can write, let us maintain a tail variable so that this operations now become O of 1. Because if I have the tail, then I have to just make sure that I am implementing few steps, right? So tail dot next and then moving my tail to the new node. That is something which we have already seen. So we will be able to move it to O1 complexity, which again is pretty good because now we don't have to worry on anything, right? Great. One more thing to mention here that in the last implementation where we use list, that is also not a lot optimized. The reason for that is we are aware that how in the backend list are using the concept of dynamic arrays, something which we have discussed already. Now, because they are using the concept of dynamic arrays, a lots of memory can get wasted, something for due to which we learned about linked list in the first place, right? So if we keep on appending, then it might happen that some memory is not being used and that is getting wasted. In very big systems, this is actually a concern. So that's why we are discussing everything in detail. Because when we make a system, let's say, which is being used by billions of people, somewhere, let's say tomorrow, when you will crack companies like Google, Facebook, Amazon, these companies, we need that optimization to the utmost level. So even if some memory is getting wasted, when that will get transformed to millions of users, it will be a lots of memory which we want to save. Okay, great. So now let us move forward everyone and discuss on another operation which we thought, which was size. Now for size, again, we will have to do the same thing. As of now, I have just the head and my tail, but I cannot get the size using this, right? Because if I will try, there is no way. Like tail just tells that, hey, I am the last one. Head tells I am the first one. How many are there in between? You cannot tell. So again, I will have to do the same thing. Make a temp variable starting from head. Keep on moving temp variable until it becomes none. And the way we find out the length of our linked list, right? So that is something which we have to do. Again, that's an ON approach, right? So let me just write that down. Will be O of n in complexity, right? So if it is O of n in complexity, then of course, something which I want that I can make it a little better. For this, what we can do, what I believe we can do is we can maintain a size variable or length variable overall. Okay, size or length. So every time you are adding something, I'm just going to increase that by 1. If you are removing something, then I will just do -1. Okay, great. If that is there, then of course, is empty also becomes a lot easier. Is empty function is also a lot easier to implement because I can just check if my size is 0 or not. Size or length will be maintained. So I'm writing all these things down so that you can refer to these notes going forward before your interviews or any other time, right? Will be maintained. Great. So that is done. Now the next one is going to be a lot easy, I believe then. It's is empty, right? Is empty is something which we can do very easily now. Size equal to 0. Similarly, peak or top is a lot easy as well. We can just return, the data which is on my tail, right? Anything which is on my tail, I can just say that, hey, that's the top element, because this is how we are adding our elements, right? 1, 2, 3, 4. So up till now, I think we don't have any problem. Each and every operation we are able to do in O1 of time. Okay, great. One operation is left, which is our final operation, which is pop. Okay, so let's see how pop can be also implemented, everyone. To implement the pop, I have to get the value which is on the last, or which is on the top of my linked list, that is, top of my stack, that is 4. But along with getting, I have to remove this value as well. I have to remove and get rid of this value. Okay. If I have to do this in my linked list, I believe that it's not that easy. Okay. Because I cannot move my tail pointer to the back, to in the back direction, right? We know that, okay, we can go to tail.next, but moving it in the backward direction is not possible. So I feel that we will face some problem. Maybe we can think that, okay, no worries. Maybe we will have some uh, second last or some element. Okay, second last element, second last, some pointer like this. What we will do with this time is, or previous, rather I should say previous, because that is something which we have seen. So maybe we can say maintain a previous here. Okay. But the problem in this previous is, the problem in this overall previous is that it's still not gonna help me. Why it will not help me? Pay attention, everyone. Let me use a different color pen. If you make tail go to previous, that's going to work one time. But how are we gonna move this previous back? This operation again is not possible. This operation is again something, everyone, which is not possible. How will you move this previous back? So what I'm saying is, pay attention. I am saying that, let's say I did stack.pop. Once you do that operation, then of course it is deleting your element, right? So we will make sure that we are putting out our this element. Okay, that makes sense, right? Let me draw it in green so we can connect with it. So this is what pop is, right? So now ideally, how my linked list should transform is something like this. It should be, this should be removed. Okay, this is how pop will happen. Now, if this gets removed, everyone, then I will have to make sure that somehow I can bring back my tail to this particular a node, which is 3. If I have a previous, yes, I can do that. So let's do that as well, everyone. I can bring it back to previous. But the problem arises if I ask you to do the pop again. How are you now going to move to the second node? I hope each and every one of you are able to understand that using previous, I can do pop one time. But if you have to do multiple pops, then we will have to find some way through which we can reach to second node. Okay. And I hope you can see that why that's the problem. You cannot. We will not be maintaining pointers to each and every node. That will defeat the purpose. Okay. We cannot actually say or travel backwards. Now, if any of you are thinking that maybe we can use a doubly linked list where we have this kind of a functionality, well, again, that is also a problem. Okay, because that is going to take a lots of space again. Okay, we will be having multiple pointers just for this one operation. We are using doubly linked list, which will again be using lots of pointers. Okay, so what we have to do rather in this case is, again, it will be O of n. Okay, use a temp to travel. Now, how will that happen? I will start with a temp here. I will go till I say that, hey, the next node is a tail node. So my temp will go here, and finally I will make my tail say, hey, that can you please be the temp variable? Okay. So this is how we will be actually doing this, everyone. I hope each and every one of you are able to understand the complexity and the reason I'm going with this temp and how this previous will not cut it. I will repeat it once again. Let's say if I have to delete this 3. I had this previous when I deleted 4. So one pop can be nicely done. But if you have to do multiple pop, if let's say, and which we might have to do, right? It's a stack. You cannot say your user that, hey, please don't do that. Please don't go back 2 times. Please don't undo 2 times. You cannot say something like that. Please don't store more than 2 functions in my call stack. These are not the things which a language or which a product says to you, right? So for that matter, what we might have to do is we might have to now again start with a temp variable. Keep on moving this temp until we find the next as tail. So temp will stop here. If there would have been 4 elements, it would have stopped here. And I will have to ask my tail to become temp. Thus making the full complexity of this pop function as O of n. Okay. Though it is still doable, like I'm not saying that you cannot do that. I still believe that since we are using stack, we are understanding a new data structure, and we are spending so much time, we should be able to do these operations in a constant time, because we have in a way limited our operations. And still, if I have to take so much time, then I believe that's a problem. Okay. So I hope each and every one of you are able to understand the problem. Let me write it down as well, everyone. Due to pop function, we, let me write the function completely, 1 second. Pop function, we cannot do it in better complexity than big O of n. So this much complexity of course will be done, will be there. Okay. Which is doable, which is doable. I'm not saying that you should not do it. Just that I would like to, okay, since there are so much less operations, would like to reduce it as well. And to go back where it all started, if implementing stack using linked list, right, everyone? So I hope each and every one of you are able to understand this problem. You can implement linked list, stack using linked list, but we have one bottleneck that pop will be O of n. We were able to solve all the other 4 operations. We were able to solve on push by maintaining a tail, size by maintaining a size or length variable, is empty and peak as well were helpful in the same way. Pop is something which we cannot solve. Okay. So I will now leave you to this thought. Let us see what exactly can be done. Maybe you can try to think on what might be the solution. And in the next video, we will understand what can be the solution and also try to code the full thing. Okay. So great, everyone. Please try to just think on this solution. And I hope you understand what exactly is the bottleneck here. Okay. Thank you.